Welcome back, everyone. Ready for another deep dive?
Always.
All right. Today we're taking on a topic that might seem, well, a bit dry at first glance.
Oh, I wouldn't say that.
I know. But hear me out. We're diving into the world of testing.
Ah, testing. It's more exciting than it sounds, I promise.
That's what I'm hoping you'll help me prove. We've got two sources to guide us today. SAE, Test and Verification R555, and Testing of Complex and Embedded Systems.
Sounds like a solid foundation.
And from those, I'm hoping we can uncover some surprising insights. See, when I think testing, I think software, maybe a few crash test dummies.
The usual suspects.
Right. But I have a feeling this deep dive is going to reveal that testing is way more than that. It's not just about lines of code or making sure cars don't explode on impact.
You're catching on already. Testing is everywhere. It's woven into the fabric of just about every industry you can imagine.
Okay, now you got my attention. Paint me a picture. What does testing look like outside of, say, Silicon Valley?
Well, let's take a crime scene. Imagine a blood stain.
Whoa, getting dark already.
Just setting the scene. So that blood stain needs to be tested. Not just to confirm it's blood, but also to see if it matches the suspect, right?
Okay, yeah, makes sense.
Or how about something a bit less intense? Let's talk cars. Before any new model hits the road, it goes through rigorous crash tests, making sure it meets strict safety standards.
Yeah, I've seen those videos. It's pretty intense watching those cars get smashed up.
Exactly, and that's just one small part of it. Even the clothes you're wearing right now, the chair you're sitting on, they've all been tested in some way. Durability, performance, you name it.
Wow, I never thought about it like that. So everything around us has been tested at some point.
Pretty much. And the core principle behind all these different tests is surprisingly simple. You're measuring something against a predetermined set of criteria.
So it's not just about finding flaws, it's about understanding how things work or don't work under specific conditions.
Exactly. It's about gathering evidence and making informed decisions based on the results. Now, speaking of different conditions, with so many things to test, there must be a ton of different approaches, right?
Like me. Our sources mention a whole laundry list of testing types. Functional, performance, compatibility, security, usability, the list goes on.
It can definitely get overwhelming, but each type of testing serves a specific purpose.
Like with functional testing. That's basically making sure the product does what it's supposed to, right?
Right, like think about your phone. Functional testing would be making sure all the buttons actually work, the camera takes pictures, the basics.
So making sure that when you tap the camera icon, it actually opens the camera app and not like your email inbox.
Exactly. Sounds simple, but it's crucial.
Okay, that makes sense. What about performance testing? That sounds a bit more intense.
It is. Imagine you're launching a new website expecting tons of visitors. Performance testing would involve simulating all that traffic, seeing how the website holds up under pressure.
Ah, so that's how companies avoid those website meltdowns when everyone's trying to snag tickets to a hot concert.
Precisely. It's about identifying bottlenecks, making sure the user experience is smooth even when things get crazy.
Makes sense. Any other types of testing from the source that jumped out at you?
Oh, definitely. One that's particularly interesting is salt fog testing.
Salt fog. What in the world is that?
It's especially crucial for industries dealing with harsh environments. Think cars, ships, outdoor infrastructure, things exposed to the elements. Basically, they subject the materials to a super corrosive salt fog.
Great. So they're basically recreating the worst coastal weather in a lab.
Exactly. It's all about seeing how these materials hold up against rust and degradation, trying to predict long-term durability.
Interesting. So it sounds like testing isn't just about catching bugs or glitches. It's about ensuring quality, safety, and ultimately making sure the user has a good experience.
Couldn't have said it better myself. And that brings us to a crucial point that both sources emphasize, the importance of thorough testing.
Yeah, Chapter 8 of Testing of Complex and Embedded Systems really drove that point home. It painted a pretty grim picture of what can happen when testing is inadequate.
Oh, absolutely. They talk about dissatisfied customers, damaged reputations, even legal repercussions if safety standards aren't met.
It's a stark reminder that cutting corners on testing can backfire in a big way.
It really can. Think about a major software glitch or product recall. The consequences can be devastating, both financially and for the company's reputation.
Okay, point taken. Thorough testing is crucial. But how do the experts actually go about it? The sources mention some pretty intriguing techniques.
There are tons of techniques, but one that comes up often is black box testing.
Black box. That sounds mysterious.
It is, in a way. It's a method where you focus solely on the inputs and outputs of a system without knowing how it works internally.
So it's like trying to figure out how a car engine works just by observing the gas pedal and the wheels turning without ever popping the hood.
That's a great analogy. You're just looking at what goes in and what comes out, evaluating the functionality based on external behavior.
Interesting. So what about this equivalence partitioning thing I saw mentioned? That sounds incredibly complicated.
Don't let the name scare you. It's actually a clever way to streamline testing. Let's say you're testing software that accepts numbers as input. You wouldn't test every single number, right? That would take forever.
Yeah, that sounds like a recipe for burnout.
Instead, you divide the range of numbers into groups, these partitions that you expect to behave similarly. Then you test a few representatives from each group.
So it's like taking a strategic sample instead of testing the entire universe of possibilities.
Exactly. It makes testing much more efficient, especially for large and complex systems.
Smart. Okay, one more technique that caught my eye. The Dunning-Kruger effect in testing. What in the world is that about?
Now we're getting into the psychology of testing.
Oh, this should be good.
The Dunning-Kruger effect is a cognitive bias where people with low competence in something tend to overestimate their abilities.
Oh, yeah. I've definitely experienced that in other areas of life. But how does that apply to testing?
Well, imagine an inexperienced tester who's super confident in their skills. They might miss crucial flaws because they think they've covered everything, when in reality, they don't even know what they don't know.
Yikes. That's a scary thought. It really highlights the importance of having experienced and knowledgeable testers on board.
Absolutely. You need people who know what they're doing and are aware of their own limitations, which is why continuous learning and professional development are so crucial in this field.
Okay, we've covered some fascinating ground here, from blood stains to salt fog to the psychology of testing. But I'm curious about something else with this much emphasis on thorough testing. How do teams balance the cost of testing with the risk of something going wrong?
That's a great question, and it's something that Chapter 2.5 of Testing of Complex and Embedded Systems dives into.
Oh, what do they say?
They warn against skimping on testing just to save money.
Which makes sense, because as we've discussed, the consequences of inadequate testing can be way more costly in the long run. But how do you determine the right amount of testing?
That's the million-dollar question. There's no one-size-fits-all answer.
Figures.
It really depends on the complexity of what you're testing, the potential impact of a failure, and any industry regulations that need to be met.
So a simple app would probably require less rigorous testing than, say, a medical device or a self-driving car, where the stakes are much higher.
Exactly. It's all about assessing the level of risk and allocating resources accordingly.
And I imagine experience plays a role here too. A seasoned tester would have a better intuition for where to focus their efforts.
Absolutely. They've seen firsthand what can go wrong and have a deeper understanding of the potential pitfalls.
Okay, all of this is starting to make a lot of sense, but I'm curious about something else. The testing environment itself. I mean, we talked about salt fog chambers, but I imagine there's a whole range of settings where testing takes place. Labs, the real world, maybe even virtual spaces.
You're right. Both sources touch on the importance of choosing the right environment for the job.
So the where of testing is just as important as the how.
Absolutely. You've got controlled lab settings, real-world field testing, and then simulations and emulations. Each has its own pros and cons.
Give me the rundown. What are the advantages and disadvantages of each?
Well, labs are great for controlling variables, but they don't always capture the messy reality of how a product is actually used. Field testing gives you real-world data, but it can be hard to control all the factors at play. And simulations, well, they let you explore a wider range of scenarios safely and efficiently.
It's all about picking the right tool for the job, or in this case, the right environment for the test. Okay, now here's something that really caught my eye in the source material. The emphasis on the human factor in testing. It's not just about the technology, it's about the people behind it, right?
That's a crucial point. Chapter 11 of Testing of Complex and Embedded Systems goes into this in detail.
All right, spill the beans. How do our own brains and biases potentially mess up the testing process?
Well, they talk about something called test engineer bias, which is basically the tendency to design tests that confirm our own assumptions rather than objectively evaluating a product.
So it's like subconsciously wanting our creation to succeed so we might overlook potential flaws.
Exactly. We all have biases, and it's important to be aware of them, especially when it comes to testing.
Right, because ultimately the goal is to create a great product, not just to stroke our own egos.
Precisely. And then there's the issue of in-group bias.
The in-group bias.
Yeah, it's this tendency to favor your own team's work over others, which can skew testing outcomes.
So it's like having those fresh eyes on a project. Someone from outside the core team can be super valuable.
Exactly. It helps challenge assumptions and ensures a more balanced perspective.
Makes sense. What other human factors did they highlight?
Well, there's the halo effect, where a positive impression in one area can influence our judgment in others.
Oh, well, I'm definitely guilty of that.
Yeah,
Like if a product looks really sleek and visually appealing, I might be more forgiving of minor functionality issues.
exactly. And then there's the classic planning fallacy, where we underestimate how long things will take.
Ah, that one gets me every time.
It can lead to rush testing and potentially missed defects.
So it seems like self-awareness, objectivity, and a healthy dose of realism are crucial for any tester.
Absolutely. And that's why diverse testing teams are so valuable. Different perspectives can help catch blind spots and lead to a more robust testing process.
I'm really starting to see the depth and complexity of testing here. It's not just about running a few scripts. It requires critical thinking, attention to detail, and a deep understanding of human psychology.
Well said. And remember, both sources emphasize that testing is not a one-time event, it's a continuous process that should be woven into every stage of development.
So it's not just about finding and fixing bugs. It's about constantly learning, evolving, and striving for improvement.
Exactly. Testing is an ongoing dialogue between creators and their creations, a quest for quality that never truly ends.
I love that perspective.
Yeah.
It's not about achieving perfection, but about embracing the iterative nature of development and always seeking ways to make things better.
Precisely. And that's where concepts like continuous testing and feedback loops come in. It's about integrating testing into the very fabric of development and using the insights gained to drive innovation.
Okay, I'm definitely starting to see the bigger picture here. Testing isn't just about catching errors. It's a fundamental part of creating anything worthwhile, anything we want to put out into the world.
Exactly. It's about understanding, evaluating, and ultimately improving the world around us.
Well, we've covered a ton of ground here. From bloodstains to salt fog, black boxes to the quirks of human psychology, we've explored so much.
It's been quite a journey.
It has. But I have a feeling we're just scratching the surface of this fascinating field. And good news, everyone, we'll be back in part 2 of this deep dive to delve deeper into even more intriguing concepts and techniques. We'll be exploring statistical analysis, simulations, and the crucial role of ethics in reporting test results.
Stay tuned. We've got plenty more to unpack.
Can't wait. But for now, I think our brains need a little break to process all this awesome information. See you back here soon for part 2 of our testing extravaganza.
Welcome back to our deep dive into the world of testing. Before we get too far, I think it's worth circling back to something we touched on earlier, the different environments where testing takes place.
Yeah, good point. We talked about labs, field testing, and simulations, but I'd love to hear more about when you might choose one over the other. Like, what are the pros and cons of each?
Well, it all depends on what you're testing and what you want to learn, right? Labs offer this controlled environment. You can really isolate variables and eliminate those external factors. But of course, that also means they might not fully capture the messiness of real-world usage.
So a lab is great for getting clean, consistent data.
But it might not tell you how a product will actually behave in the hands of a real live user.
Exactly, and that's where field testing comes in. Putting your product out there with actual users in their natural environment can provide some truly invaluable feedback.
Right. I can see how that would be essential for, say, a mobile app. User experience is everything, right? But what about those cases where real-world testing just isn't feasible or maybe even safe?
That's where simulations come in. It's like creating a virtual representation of a real-world scenario. You can test a huge range of conditions without needing physical prototypes or putting anyone at risk.
So for something like a self-driving car, you wouldn't want to test every possible traffic situation on real roads, right? That would be chaos. Exactly. Simulations let you explore those edge cases safely and efficiently. You can test different weather conditions, pedestrian behaviors, all sorts of things.
Sounds like simulations can save a lot of time, money, and maybe even lives.
Yeah.
But are there ever times when nothing beats real-world testing?
Absolutely. Like if you're testing a new type of bridge material, eventually you're going to need to see how it holds up under real-world stresses and strains. No simulation can perfectly replicate the complexity of the physical world.
Makes sense. So choosing the right testing environment really comes down to understanding the trade-offs and picking the approach that aligns with what you're trying to achieve.
Exactly. It's about finding that sweet spot between control, realism, and, well, feasibility.
Okay, so we've got our environments, but now I'm curious about the techniques themselves, the things that bring a more analytical lens to testing. We mentioned statistical analysis before the break.
Yeah, statistics are essential, especially when you're dealing with lots of data or trying to draw solid conclusions.
All right, help me wrap my head around this. How would you use statistics when testing a new software feature, for example?
Okay, imagine you're testing a new feature that's supposed to make a website load faster. You'd run tests with the feature enabled and disabled, right? Then collect all sorts of data, page load times, server response times, all that good stuff.
Right, so you're comparing how the website performs with and without the new feature. But wouldn't you just be able to tell if it's faster or not?
Mm.
Why bring statistics into it?
It's not always that clear cut. Statistics help you determine if those differences are, well, statistically significant.
Statistically significant. I feel like I've heard that term thrown around, but I'm not sure I fully grasp it.
It basically means the difference you're seeing is probably not due to random chance. It gives you more confidence that the improvement is actually because of the new feature, not just some fluke in the data.
Ah, okay. So statistics help you separate the real deal from the random noise. Makes sense.
Exactly. Plus, they can help you calculate things like confidence intervals, which tell you how reliable your results are.
So a wide confidence interval means you're less certain about the results, and a narrow one means you can be more confident.
You got it. And remember those pesky intermittent failures we talked about earlier? Those bugs that pop up once in a blue moon and then vanish?
Oh, don't remind me. Those are the worst.
I'm
You
sorry.
can never seem to reproduce them consistently.
Well, statistics can sometimes help you find clues in the data. You might spot patterns that point to the root cause, even if you can't make the bug happen on demand.
Wow, that's pretty cool. So statistics are like this secret weapon that helps testers make sense of complex data. Anything else we should know about in terms of analytical techniques?
Well, we've talked about simulations a bit, but there's also emulation.
I feel like I've heard those terms used interchangeably. Is there a difference?
There is. Think of it this way. Simulation is like creating a virtual model of a system, like we talked about with the self-driving car. Emulation is more about mimicking the behavior of a specific piece of hardware.
So if you're testing a new piece of software, you might use emulation to see how it runs on a specific type of phone.
Exactly. It's all about ensuring compatibility and performance on a particular platform.
It seems like both simulation and emulation can really streamline the testing process.
Absolutely. They let you experiment and iterate quickly without needing all the physical resources.
I'm sensing a theme here. Working smarter, not harder. Okay, so we've talked about environments, techniques, and now I'm curious about something else that both sources bring up, the importance of ethics.
Ah, yes. Ethics in testing. It's crucial.
I have to admit, I wouldn't have immediately thought of ethics when it comes to testing. Let me understand what that entails.
It's about making sure the testing process is done with integrity. That means objectivity, honesty, and a commitment to accuracy.
So, testers have a responsibility to report their findings honestly, even if it uncovers some unpleasant truths about the product.
Exactly. No sugarcoating. Ethical testing builds trust, and ultimately that leads to better products and better outcomes for everyone.
Right, because if you're only focusing on the good stuff and hiding the bad, you're not really getting an accurate picture of the product, are you?
You got it. It's about being transparent and accountable, even when it's tough.
Okay, I'm definitely seeing a deeper side to this whole testing thing. It's not just about technical skills, it's about having a strong moral compass, too.
Absolutely. Ethical testing is about doing what's right, even when nobody's looking over your shoulder.
Love that. So we've learned that testing is this multifaceted beast. It's about understanding complex systems, using data wisely, and of course, sticking to those ethical principles.
Couldn't have said it better myself. It's a field that demands both technical expertise and a rock-solid moral compass.
And I'm sure there's even more to it than we've covered here.
Oh, definitely. There's always more to learn.
Well, good news for our listeners.
Yeah,
We're not done yet. We've got one more part to go.
that's right. In part 3, we're going to dive even deeper into the human side of testing. We'll talk about communication, collaboration, and the importance of continuous learning.
Can't wait. Stay tuned, listeners. We'll be back after a quick break for the final leg of our testing journey. And we're back for the final part of our deep dive into the world of testing. We've covered so much ground already, different types of testing, those tricky testing environments, even the role of statistics and simulations. But, through all of that, I keep coming back to the human element. With all this talk about technical processes and analysis, where do the people fit in?
It's a great observation, and honestly, it's something that both of our sources emphasize. Testing at its core isn't just about running scripts or following a checklist. It's a human endeavor. It's about communication, collaboration, and this constant drive to learn and grow.
Okay, now, I'm really intrigued. Break it down for me. How is communication so crucial in testing? I mean, it seems pretty straightforward, right? You run the test, you get the results, you report them. End of story.
Oh, if only it were that simple. Effective communication, it's essential at every single stage of the process. Testers need to be able to clearly explain what they're doing, how they're doing it, and what they find. And not just to other testers, but to developers, project managers, all the stakeholders.
Right, because if those test results aren't communicated clearly, they might get misinterpreted, leading to
Mhm.
all sorts of problems down the line. Delays, reworks, you name it.
Exactly. You need to create a culture where everyone understands just how important testing is and feels comfortable speaking up, sharing their concerns, asking questions.
So it's not just a one-way street. It's a constant dialogue throughout the entire process.
Absolutely. And that leads right into another key element, collaboration. Testing, it's not a solo mission, it takes a team.
Yeah.
Testers, developers, designers, product managers, everyone working together.
Okay, I'm getting that. But paint me a picture. What does that collaboration actually look like in the real world?
Well, let's say you've got a team working on a new mobile app. The testers, they might work closely with the developers to really understand the code, see where the potential weak spots are. At the same time, they might be working with the designers to make sure the user interface is intuitive and testable.
Oh, right, because if the interface is a nightmare to navigate, it's going to be that much harder to test the app's features.
Exactly. Collaboration is all about breaking down those silos. Everyone needs a shared understanding of the product, the goals of the testing, everything. It's how you create a truly great product.
Okay, communication and collaboration, two sides of the same coin.
Got it.
But what about this continuous learning thing?
Hmm.
Why is that so important in the world of testing?
Well, think about it. The tech world is constantly changing. New tools pop up every day, new frameworks, new methodologies. A tester who's not constantly learning, they're going to fall behind.
Yeah, it's like that saying, if you're not moving forward, you're falling behind.
Exactly. Testers, they need to embrace a growth mindset. They need to be attending conferences, reading up on the latest trends, experimenting with new tools. It's a lifelong journey of learning.
So it's not about mastering a set of skills and then just coasting. It's about pushing yourself to keep learning, to keep growing.
Absolutely. The best testers out there, they're the ones who are always asking questions, always curious, always pushing the boundaries. They're passionate about what they do.
When we started this deep dive, I had this image of testing as this super dry technical field. But now I'm seeing it in a whole new light. It's about problem solving. It's about critical thinking. It's even, dare I say, creative.
I'm so glad to hear that. It's challenging, it's rewarding, and it's definitely never boring.
Well, I think we've covered just about everything there is to cover on testing. From bloodstains to salt fog, from black boxes to the mysteries of the human mind, we've explored it all.
It's been an amazing journey.
It really has. And a huge thank you to you, our expert, for guiding us through this incredible world.
It's been my pleasure. I always love diving into this topic.
And to our listeners, thank you for joining us on this deep dive into the fascinating world of testing. We hope you've learned something new. And maybe, just maybe, you're seeing the world around you with a slightly